Good morning. Welcome to the JagCorner. Sorry I'm a bit late this morning. My internet went out for like 1 minute and then it came back on. So hopefully the stream stays stays up this morning. I honestly don't know if it's going to or not. Um, Today we're going to be doing some programming. We're going to continue our work on the 240p test suite, which is just a set of tools that are used to. I just noticed that this is a little too squished. A set of tools to calibrate CRT, calibrate monitors in general, specifically CRTs, and to test things like lag and your controllers and stuff like that. I did do a little bit of a follow-up last week. Last week we were doing games, and so I made quite a bit of headway since the last time I worked on stream with the 240p test suite. There we go. Most of it's just static elements, and so a lot of that programming wasn't too difficult. I've been looking at the code on. In fact, I need to get that all set up here, so maybe we'll spend some time doing that. I've been looking at the code for the 240p test suite, specifically for the Mega Drive version. I honestly don't know if that's the best version I should be looking at. I probably should be looking more at the Dreamcast, because I imagine there will probably be a lot less platform-specific calls in the code. I need to go take a look at that. But what I've been doing to really match what's going on is I've just pulled up the Mega Drive version in Mednafen. I should probably get my Sega Genesis out and get a cart or something. But and I've just been matching the functionality there. I figured once we get a first pass on the program done, what I'll do is I'll probably run this past some people on the forums and probably the people who are in charge of the GitHub for the 240p test suite, and make sure that everything is I don't want to say good enough, but good enough. And if there's some things that I'm not doing quite right, we can work those out over time. But here's just a quick look. Let me pull this up on the big screen. So we have our Pluge, which is just for calibrating black and white, and my LCD is absolutely, well, it's not terrible. I can just barely see the left bar, but not the other two bars. So definitely needs some calibration. You got that. We got color bars, which is gradient. Make sure your contrast and brightness are good. EBU, which is your European color bars. And I actually, my brother sat down. So my brother, he does, he grew up right when CRTs, or he was learning about these technologies right when CRTs were going out the door. And so he actually learned how to properly use color bars for color calibration. You need specific tools for that. And I mentioned this last time, it'd be cool to get him on stream to actually demonstrate this. I'm sure there's other videos out there, but it'd be cool to use a Jag to do it, right? So we may do that. But yeah, this is used. It also has the Pluge down in the bottom right. But what's cool about this, the colors are set up in such a way that you do something called a blue screen or a blue mode or something like that. And it makes everything blue. But then what you do is you can adjust your phase, your contrast, your brightness and your contrast. Your phase is usually just your vibrancy, saturation. And if I remember right. And what it looks like, and I can't show you here, but what it's supposed to look like is every other bar is supposed to create this checkerboard effect where it's all white and all black with those colors, but because you're using this all blue, it looks like a blue checkerboard, which is, it's really cool. And that's how you know you have pretty darn good calibration, is once you have that nice high contrast checkerboard. It's cool to see in person how it works. I don't completely understand why those colors work that way. I haven't thought through it that much, but it's pretty cool looking. Anyways, and then there's 100% versus 75. There's a reason for that. He actually, I don't think he could explain that. I can't remember if he could explain that or not, but my brother, but it's there. Reference color bars, color bleed check. And so you have your checkerboard and your lines, check color bleed. And if you look at the stream, we definitely have bleed going on, but it's not too bad. I'm hooked up with an OSSC with RGB SCART, and honestly, it's probably my cable, because it's just it's a third-party cable. It does the job. It works well enough. But and then a Monoscope, which allows you to test things like your pixel aspect ratio with the so the red bars there should be a perfect square. And what I've done is I've actually just matched this to my LCD, and it's pretty close. It's still a little off, but it's close enough. But also on a CRT, it's really good for testing bowing, especially on the left and right side. Those squares will bow in and out sometimes, depending on your monitor. And convergence. And convergence is just so you have 3 beams going on, I assume. Somebody correct me if I'm wrong on this, for red, green, and blue. And typically on CRTs, closer to the middle of the screen you are, the better the convergence. So those beams are hitting right where they should be, and as you go out towards the edges, and especially the corners, those colors will separate a little bit. They call that convergence. It's similar to chromatic. Well, I shouldn't say similar. It looks similar to like chromatic aberration with lens. When light passes through a lens, you'll towards the edges you'll get a separation of red, green, and blue. It's not the same thing. I'm just saying visually it kind of looks the same. Yeah. So there's Monoscope, and the Monoscope is really just kind of it's used. It's an all-in-one place to test all those things, but you can also use, for example, the grid here. This is specifically for NTSC. The red kind of shows you about where the overscan is going to be on most monitors. And now if you're playing on an LCD, you're going to be seeing everything. On a CRT, those red boxes are going to be mostly covered up, depending on the CRT. I'm not sure what this gray mode is. It's in the Mega Drive version, so I decided to do it here as well. And then we have a gray ramp. Again, this is just a color contrast thing. I just noticed my capture is a little green for some reason. I wonder why that is. Let me see. This is why something like this is nice. Is it that ruined our contrast, didn't it? Yeah, we're just a little green. My monitor, my LCD looks fine. It's you know what it is. It's my AverMedia capture device. I've noticed with these AverMedias that process everything H.264, everything comes out a little green, just slightly. Some are worse than others, and I think that has to do with age. But yeah, I've noticed that with some AverMedia devices, and I don't know if that's the device itself or if that's just H.264. You have to account for that and adjust for that when you do that conversion. But I've noticed that. It seems like with H.264, because I work with encoding video a lot in my day job, that it actually makes things bluer. I don't know why. It just seems to do that. I'm probably just not encoding it correctly with FFmpeg or something. But okay. Okay, so this is just white and RGB screen, so you have red, green, and blue. So if you just tap A on the controller, it will cycle through those. If you tap C on white, it gives you a custom, and I have this cool little cursor. Allows you to come in here and adjust your red, green, and blue values. It's a 16-bit value, 556, so 5 bits for red, 5 bits for blue, and 6 bits for green, and that's why it's RBG rather than RGB. And that this may change in the future because it may confuse people, but that's just how the Jaguar is set up. That's how it encodes the data, and so that's how I like to represent it whenever we create a visual representation for the user. Just so, especially for a programmer, it's nice to know that. It took me a while to figure that out because in the Jaguar reference manual, the SDK, this developer documents, the developer manual, that's what I'm looking for. I think it's only mentioned once. I remember the last time I was looking, when I was trying to figure how to do color fades and stuff. I'm like, seemed like I read somewhere that the color order is different, and so I dove into the manual, and I read a lot of the manual just to find that one reference, because it took me a while to find it. I could be wrong that it's mentioned differently elsewhere. I know it talks about cry color quite a bit, and so maybe they're like, yeah, most people understand this RGB, or in this case RBG thing. Let's move on to our cool cry color system. Anyways, it kind of seems like it's brushed over really quick. But if I was more familiar with looking at assembler files and things like that, it probably would have been a bit more obvious to me that that's how it was set up. Anyways, but I got it figured out now. And I've actually shown on stream some cool ways in C code that you can quickly encode 556 color in one line. It's kind of nice. Anyways, so there's that. I don't have this 100 IRE. I need to talk to somebody about this eventually. See if there's a specific way I need to set that up. With an oscilloscope or something, to make sure that the different values, so it steps through several different values of white, this white box on the screen, and I want to make sure I get those values correct, so that test is actually useful for somebody. I assume it's somebody who's using an oscilloscope. That's where something like this is really useful, so you can really key in your brightness or amplitude, or how much voltage is going into the CRT or something. That's my impression. I need to go do some more reading on it and talk to some people, but there's a sharpness, and this is actually really cool. I actually use this on a few of my monitors, and you can really tell what will happen. I can't really point at anything, but the black lines, where the black and gray meets, so a point of high contrast, if your sharpness is turned up, you'll see these little white, they call it white ghosting. It's just, it gets subtly white around the edge. And so if you turn your sharpness down, it will get rid of that. So, and it seems like some monitors, they do better with that than others. And yeah. Overscan, this one's kind of cool, because this is actually how you check how much overscan. And it's going to be hard to see here on stream. I really need to get a camera set up on a CRT to show this off. But basically you go, for example, the top, you go down until you see the first shred of white, and then you go back. And so right now I have 1 pixel of overscan here on the stream. And then you just tap A to go to the next one, and you push up to push the bottom one. See, this one has a little bit more. That has 4 pixels. And then the left actually has a negative, but you can't do negative here. And then the right is right where it needs to be. So, and then if you hit C, it just resets those values. So, and then convergence is a set of, this won't show up right now, actually. This will crash because it's unpacking too many. I'm pretty sure what it's doing is it's filling up memory, and then it hits the end of memory and crashes. So let me reset that really quick, because there's one more thing. Did that work? Yeah, it did. Right. Send that back over. Yeah, so what it's doing is there's like 4 or 5 images that it's unpacking, and they're really big right now. What I need to do is convert them all to 8-bit, to an 8-bit color palette, because it's only a few colors. And in fact, I could probably do it right now. Maybe we'll spend some time doing that and get that working. I'm not too worried about it, because once this is a ROM and on a cart, it doesn't matter. There's plenty of memory for it all to fit in there. Yeah. And I think that's it. I have some basic things. So if you hold down, you can scroll through the menu lists like that, which is nice. Just convenient. And so you can go in and out of menus. I also, just some other things that I figured out. I figured out how to cut between these 2 menus without there being any on-screen loading things, loading artifacts like text lines moving around or filling out. Just I've learned some cool things here that I'm going to be able to use in the games. And so this, I know some people may be thinking, well, why aren't you just working on the game? And to be honest, it's uh, um, I've been a little burnt out on it, and so going over to a project like this kind of helps out with that. But it also gives me an opportunity to do things that I wouldn't typically do in the game, but may teach me things that are useful for the game. And that's kind of hard to explain. But there is one more thing that was useful to figure out. So I haven't figured out how to do scrolling that works really well in my games so far. If you're just scrolling sprites on the screen, individual strips of sprites or squares of sprites, you're kind of limited in how much you can put on screen before things start slowing down. But with I thinking through the hierarchy of how the removers library is set up. So you have your display buffer, and this is just where everything's put on the screen. And in that display buffer, you have 16 layers. And in those 16 layers, you can have 256 sprites. So what I was doing, for example, for Flappy McFur, I just have all, I just, like, for example, the background scrolls, right? And the pipes scroll with that. I have those on one display layer, and then I'm moving the sprites individually. What I've learned here is what I should be doing is putting certain things on specific display layers, and instead of scrolling the sprites, I scroll the display layer. And what I do is I double up. I use 2 or 3 display layers to create the infinite scroll effect. And that works. And I learned that here with this scrolling test. And it works fantastic. Like, smooth as butter. It looks great. There's a little bit, for some reason, there's a little bit jitter on the stream. And I don't know if that's my computer or maybe it is smooth as butter on the stream. I can't quite tell, but on my monitor, it's absolutely wonderful. And so that is an incredibly useful thing to learn. So I may be going through and recoding how Flappy McFur scrolls to make that as optimized as possible. And then I'm going to use it also for the title screen on Oddball. There's these clouds that are scrolling down the bottom, and right now I have them really pushing the limits because they're big sprites that are scrolling, or it's one sprite that it's tileable, horizontally tileable, and right now it's going down the bottom. And the way I've optimized it is I've just pushed it down pixel by pixel until everything's running smoothly. And so to give you an idea of what scrolling sprites individually, how much that slows things down. And I think it just has to do with how the Jaguar handles graphics. It's not using, I think they're called bit planes that other platforms use. Like, I'm pretty sure the Mega Drive, Sega Genesis, uses bit planes, and so does the Atari ST. The Jaguar uses something called a line buffer, and I don't completely understand this. I was actually reading about this yesterday a little bit, but it does everything per scan line rather than in block chunks in virtual space. So this is before it hits the actual scan line on the CRT. It's actually it takes an object list, and according to that list and how things are sorted in that list, it paints the first set of pixels in the buffer, and it does that per line. And so when you're doing it by sprite, for some reason that's slower than doing an entire layer in the display. I don't completely understand it, but that's how it works. Here, 1 second. I just realized my chat is not working on my screen. I can see it in the stream, but not on my screen. Hi, wow, this scrolling looks nice. Sounds interesting what you did here, actually. Hi, Will. Hi, Dataset. Hope all is well. Good to see you guys. Thanks for dropping in. Give me just a second. I'm going to, for some reason, my chat is not functioning as I expect it to. There it is. Got it. Okay, cool. It's working fine on inside the stream, but it's not working fine on my desktop where I can see it conveniently. Yeah, so got scrolling going on. we may spend some time with this. Right now I'm kind of cheating the parallax effect. There's actually a mathematical way to do this. I don't understand it though. And so the way I did it is I just hard coded the how much the background's moving versus the foreground. And there is actually a way I could do it this way without doing the math, but yeah, thanks. Yeah, the scrolling looks great. And I was really excited that this worked out because so the foreground is just one giant sprite. It isn't like a tile map or anything. And the fact that that's scrolling over the background really, really smoothly is awesome, because that means I can do parallax effects and stuff like that if I want to now. I've learned how to do that. So it's really, really cool to see that. Oh, hey, Matt. Good to see you. Yeah, so we may not be doing any more with this. We'll be doing some less exciting stuff, I believe. But so this line buffer stuff sounds more like an Atari 2600 approach to things compared to the... See, and you're going to know more than me, dataset user. I'm not familiar with many other platforms. I know the ST uses bit planes, and so does the Sega Genesis, I believe. Yeah, I've read up a little bit. Like, I've started to learn some assembly programming on the Atari ST, but not a whole lot. And so they talk a little bit about that when they talk about graphics. All I know is the Jaguar is very different in that regard. It's interesting because a lot of platforms seem to have a dedicated space for where you manage graphics, whereas the Jaguar, it's arbitrary. You can pick anywhere in memory, and as long as you point things to the right things and say, I don't know a lot about this, it will show up on the CRT. And what that allows you to do is you can do things like different resolutions really easily by just changing the horizontal clock speed. And the way the Jaguar documentation makes it sound, it makes things like scaling sprites and polygon fills and stuff like that. It makes that stuff faster. I don't know if that's true. It's just what they're saying. Anyways, that's about the extent of my knowledge on graphics and video games. So, but it's cool to see at this high level in the C code, I've figured out a way to do this, because everything else from collision and stuff like that, that's all background, that's all virtual code. I call it virtual. It's stuff you don't see visually being calculated in the background that does manifest visually eventually, but that can all be handled with this system used to create this scrolling effect. But anyways, the other cool thing is the background. There is some animation going on, and this was really exciting too, because that's just one big sprite, the background. What I did is I took the Dreamcast assets for the 240p test suite and just brought them in here. I think on the Genesis version, they're actually creating a tile map and scrolling a tile map as you would in an actual game. Here I just took the full size sprites from the Dreamcast implementation of this, because they didn't want to do a tile map, because the Dreamcast can handle scrolling these huge sprites, and I wanted to see if the Jaguar could do it, and it looks like the Jag can handle it just fine. So we didn't have to use a tile map to do this cool smooth scrolling effect. So anyways, that was exciting to learn. In fact, I'll probably just keep this up, and so if anybody else comes into the stream, they'll be like, "Wow, is he playing Sonic the Hedgehog? What is this? I thought he was going to be programming." So anyways, let's get to coding. See what we want to do. I'm not entirely sure where I want to. What did I do? Oh, I just reloaded it. Just wanted to collapse that. There we go. Oh, something I could check. Well, let's see here. I may have this listed out somewhere. It's been a couple weeks since I've looked at this. I didn't have any time to work on this last week. Or I didn't take the time. There was time, I just didn't take the time. Let's see here. Yeah, tests is what we're working on now. Pretty sure. Is it? Sonic back data. Test. Oh yeah, H scroll test. Oh, we want to go to main. That will list it out. There's our test images, and then this is our video tests, I believe is what it's called. So there's our horizontal scroll right there. I'm thinking, oh, we could try doing the drop shadow test today. Yeah, let's try doing that. Let me get something else. Let's see here, med, nef, and let me get something else on stream. I'm gonna get, so I've been working with the I've been using the Mega Drive version as a reference. In fact, we're gonna look at their code here too, because I'm curious to see how they set up the timing. So what this is, the drop shadow test, is it just puts an image in the background and then it uses a black sprite and it flashes that black sprite every other frame to create a shadow effect. In fact, it's probably not going to look good on my CRT. I probably should have set up with S-Video today so I could actually test some stuff on my CRT. We'll see how far we get with the LCD. Maybe I'll scramble to get S-Video up on the stream. We'll see. I can't split my RGB right now, and so split my RGB so one is going into a monitor and then one is going out to my LCD or the capture device or whatever. But I can split S-Video, so I can set up S-Video on my Jag, and I have a really nice amplified splitter. And then I have an S-Video capture card in my computer specifically for this reason, because I can't split my RGB yet. I haven't figured out how to do that. And so eventually I'll do that, but so we'll see how far we get with this shadow test, because in the emulator I don't know how reliable a every other frame flash is going to be. I noticed with Phobos, some of his videos for Asterite, they were, when you get hit, your character sprite flashes, and when in a lot of his recordings, the recordings are done in the in virtual Jaguar, and so his character will just disappear, and that's a timing issue, and it's because the emulator isn't perfect. Could be the way he's recording too. And so it's, in order to properly see that, you definitely want to be on hardware, and so we should be fine on an LCD. I'm just trying to think of a game that we might be able to test out just on the Jag that has a flashing sprite for a shadow, because I think there is something on the Jag that does that, but I can't think of it right now. Anyways, let's do this drop shadow test. We're gonna, oh, that's what I was gonna do. Reboot, good morning. Good to see you. I was going to bring up this Genesis version of this so we can see what they're doing, and then we'll try to match it. Mednafen, where do I have that? I think it's just sitting in my downloads folder. Downloads, 240. Yeah, there we go. Okay, and let me see if I can get this. Hopefully this won't crash anything. Let's see here. Give me just a second. You're going to see stuff pop up on the screen. Hopefully nothing that will implicate me in some sort of crime. Window capture. This is Mednafen. I should have had this set up before the stream, but that was kind of... Oh, it looks like it won't render. Let's see if there's any options. Swap red blue. I don't think there's any options. Yeah, it doesn't like it. So yeah, it's just coming up as black. Uh-oh, everything disappeared. What happened? Oh, there we go, everything's back. Okay, so you guys won't be able to see this, but I will radio voice, or radio, what do they call that, radio play, radio performance this for you. So if I go to video, drop shadow test, yeah, so all it is they have a background, and then they have this little bug sprite, and then the shadow is just offset and flashing on and off, and it looks terrible in this emulator, but it is there. This is why I should probably purchase a cart. Well, stay as long as you can. 11 p.m. there. Wow. Yeah. Man, maybe I should be doing these in the evenings instead, because that'll probably be the middle of the day for you. So, I kind of thought that this would actually work out, and maybe this does work out for the European audience, but I don't know how many of you guys are from Europe. Maybe I should be doing this in the middle of the day. I don't know. Anyways, let's, I'm pretty sure I have, well, I don't, seems like I have, so the background is this anime girl that they have called Donna. I think I have that pulled in already, but we're going to have to go check. Let's set up our function here first. So it's just going to be a void function with no parameters. Let's see what assets we have pulled in, because I'm pretty sure this Donna background image is used in a few different places, and I may have preempted. Not there, data. There we go. I don't see her here, so I don't think we've done it yet. So we're going to create a new section just called drop shadow test. And I'm going to go make sure, see if we've done a conversion. Let's see here. I actually don't see. I'm just in my file browser right now. Oh, there she is. Well, I would like to keep her not 8-bit. I would like to do 16 bits per pixel for her. Yeah, let's do that. So I'm just going to do a quick, actually I need to crop the image really quick. Open with. Okay, Wilco, we're going to give it another try here. Leidens. So how you say your last name? I think that's right. Leidens. The J has to be silent, right? It's like Danish or something. Leidens. So let me know if that's close. I probably botched it up again. Oh, it looks like I already got her cropped. So, okay. So I'm going to just change to our graphics directory. EFX. And that's 16. What did I call it? Test suite graphics 16-bit. Oh, whoops. There we go. If we list all that, you'll see that we have Donna in here somewhere. Where is she? Yeah, there she is. And we're going to use Jag image convert. It's actually just, I think Seb calls it converter. I like giving it a more specific name. Because there is in Linux, there's an application called convert, and it's very common. It's used quite a bit. And so I wanted to make sure there was a more specific name for that. And we want it to be, it'll be RGB. We want a binary, and we don't want it to dither anything. I don't know why he has dithering on by default, but pretty sure you have to. Maybe it isn't on. Maybe that's just an old memory that's very, very close. You pronounce the first part more like lie. So, Leidens. Is that right? Leidens. So, it doesn't look like it should be hard to say, but yeah. With my Western American accent and American accent in general, I probably screw up a lot of things pronouncing Northern European names. Okay, no dithering, and I'm just going to do overwrite here. We're not overwriting anything, but I like to do that in case we do need to re-export it. And then Donna.png. And I got something wrong. What did I get wrong? Oh, I spelled dithering wrong. Dithering. And CJ, you're probably laughing right now because all of this is pretty much automatic in Jag Studio. I messed something else up. Oh, overwrite. It's not overwriting. It's overwrite. Which, yeah, you should probably laugh at that because once you start getting this many graphics in, like it is a pain in the butt to do these conversions one by one. Especially if you need to update things for a game, which happens more often with a game for sure. And then we're going to compress this. So that's Donna dot RGB. Okay, actually I'm going to show you guys this. So you'll see that we now have this Donna.RGB. That's what we got out of that. So LZ77, we're going to pack it, and we just give it our input, which is Donna.RGB, and our output, which will be Donna.LZ77. And we got a 40% on that, which isn't bad. LS-A. I don't know, LS-L? Is that what it is? Yeah. So we can come in here and look at the size for that. So our RGB image was 153K, and our compressed one is 61K. So not bad, almost 62. Rounded up at 62. Sweet. Glad I got it right, Wilco. Okay, yeah, we just need to add her in. I'm just going to copy and paste this line. That's Donna, like that. And this is a macro. And I'm only familiar enough with assembler to say that there's a, what's it called? There's a, it's under this struct thing, data definitions here. There's a macro that runs, and it's checking for this. I think I got this right. Maybe, I don't know. It's checking for this, and then it's, according to this, it does a macro on that line. So it creates an assembly, it creates all your assembly code for you, basically, on when you build. And importantly, the most important part of that is it gives us a name that we can then reference, that we can then point to. It gives us a pointer in C. That's what it does. That we can use to use it in our C code. And I'll show you that right now. So we can just take this Donna, and in our header file, we can point to that external element, and it's an unsigned 8-bit integer because it is packed. If it wasn't packed, we'd be telling it it's phrased because we want everything to be phrase aligned, which is it's a good question. I need to see if I'm properly unpacking things, because I may not be unpacking things correctly. I haven't noticed any odd behavior from unpacking and repacking. Like, I've done some stress tests and stuff, so I think it's okay. I think it is aligning correctly, but as I go on, as I learn more, I have the sneaking suspicion that unpacking an unsigned 8-bit integer block of data doesn't necessarily mean it's going to be phrase aligned, and that could lead to some issues. I don't know, though. I'm kind of trusting that Seb's function for unpacking kind of does that work for you, that aligns it all, but I'm not entirely sure. In fact, actually, I think it might be doing that. Yeah. Well, yeah, it is, because it is working fine, because you have to, at least for this 16-bit image, it has to be divisible by 8, and so that's automatically going to make it phrase aligned. Pretty sure. I don't know. I'm not going to do the math right now. Not going to do the math. Those Jag commercials won't indoctrinate me. I'm not going to do all the math all the time anyways. Okay, extern phrase, and see, this is why I'm thinking we're probably okay, is because we create a pointer, a phrase pointer for our graphics, and so that's going to be phrase line. It has to be, as long as I do the math correctly when I allocate that data. Okay, so and then we need a sprite structure that we're gonna that will actually display the sprite. So Donna sprite. There we go. There's that. And I think that's all we're going to need. No, sorry, there are a few more graphics. There is our little... So in the demo, he has this little buzz bomber. I think it's from Sonic as well. And I just need to make sure that those are cropped. So 32 by 32 pixels, and then... gosh, should we even use... What do we want to do? I think what I'm going to do is we're just going to use, so you'll see here we have our Buzz Bomber and our Buzz Bomber Shadow, but our Buzz Bomber Shadow is just a black version of the same pixels as this. So what I'm thinking is we'll just do this one, and then we'll run a little bit of code that just goes over every pixel and just turns it to a black, or points. Yeah, no, it makes it a dark color. Oh, let me think about that for a second. Yeah, we should be fine doing that. It's a 16-bit image, and so I need to think through that a little bit. I don't do procedural pixel changes very often on 16-bit graphics, and so we're gonna have to think through that. I know it's possible. I just don't think I've done it before. Okay, so we're gonna do. I'm not gonna type this all out again. Just bring in our Buzz Bomber.png, convert that, and then we'll run it through LZ77 packet Buzz Bomber.rgb and Buzz Bomber.lz77. Cool. Got that. Add another line for that. I'm just going to copy this so I don't do any typos. No typos here. There we go. And extern, I'm going to bunch these up. Extern uint 8_t Buzz Bomber. And then we need a phrase. It's Buzz Bomber data. And we need a sprite. Buzz Bomber sprite. Like that. Okay. And yeah, that's all we're going to need for this. And I'm actually going to make this really quick, or I don't know if it's going to be really quick, but I'm just going to copy one of these other functions that we use, the content in it, because it's essentially the same thing, except we're going to be bringing one additional image in and then creating an additional. Oh, I need to do that too. Let me copy this in really quick. Put this inside of a new function called, what was it called? Drop shadow test. I'm actually just going to copy that, put it up here, and make sure we're in our brackets. We do need another sprite structure. Actually, we need two. Let me think through this. Yeah, we do need to set up. We're not bringing in a block of data, but we will need another phrase for the shadow. Buzz Bomber, another phrase, another pointer of phrase type. Just making sure I'm saying that right. Buzz Bomber shadow data. Like that. I'm just going to copy that, and we're going to do a sprite as well. Sprite. Not that. Buzz Bomber shadow sprite. Like that. Okay. And now here we can. This is just our background sprite that's being loaded here. And it's 320 by 240. I'm pretty sure it's 320 by 240. Let me double check. Probably is. Yeah, so this isn't set up for PAL. So we're fine. Oh, that's something I forgot to mention too that I did since the last time we worked on this on stream was I finally figured out how to properly detect between NTSC and PAL in the removers library. There's he exposes all the applicable memory registers for Tom and Jerry. And Jerry, there's just one bit that's flipped for PAL and NTSC, and it's stored in Joy 2 for, at least it's marked as Joy, the joystick 2 in the Jerry memory registers. I think I'm saying that correctly. There might be a better way to say that. Anyways, I had to dig through the Jaguar development manual, figure out where that was being set, and then I found that equivalent in the removers library. He has that all exposed as a member, part of a structure, a member that's a part of a structure, and so all I have to do, in fact, I can show you, it's just a simple piece of code to detect that, and it's right at the beginning, if I remember right. It's been a couple weeks, so give me just a second. It should, yeah, right here. Oh, wait. Pal Ntsc. Where are you? It's not there. Oh, I think I set it in init global settings. So, sorry, I keep getting sidetracked, but I was so happy I figured this out because this is another thing that I learned that will be good for the game. Yeah, right here. So it's in the Jerry registers, the registers for joystick 2, and there's just a bit in those 32 bits. I believe it's 32 bits, or it might be just 16 bits. There's one bit at bit 4, and you just mask that and push it over, and if it's a 0, it's PAL. If it's Ntsc, is 1. And it's great. Once I know that, you can do all sorts of things. You can, oh, we're in PAL, so bump the sprite down an extra 20 pixels or 40 pixels or whatever it is, and so I do have a monitor here that supports PAL through S-Video, and so I was able to get that all set up here in the 240p test suite, which is cool. This is all great experience, so when I go to the game and figure out all the PAL stuff, I can do that now, so, which is awesome. The original release of Flappy McFur, I did do a test for PAL, and it's playable. I just don't know if it's enjoyable because I just didn't know how to do that beforehand. Kind of wish there was just something in the removers library, a little function that just returns 0 or 1. Because that should be something that's common to development, that you're making sure you're taking into account both PAL and Ntsc. I guess for modern displays it's not as big of a deal, but it just seems to me that's something basic that should just be a part of the library. Maybe I'll make that suggestion. I could be up a creek too. Maybe it's one of those things like, well, if you're good enough, you should just do it yourself. It might just be one of those things. I don't know. Seems like something. It feels as basic as controller input. That's what PAL Ntsc detection, that's what it feels like to me. Like from a developer standpoint, it should be just, I should be able to just, hey, there's a function in this library that says, let me know if it's PAL or Ntsc. Especially on the Jag, because it's pretty straightforward with resolutions and stuff. Most games are 320 by 240 or 320 by what's PAL, 280, 86, 288, something like that. So anyways, okay, where was I? So we're a 320 by 240 image, and it's times 2 because it's 16 bits per pixel rather than 8 bits per pixel. And we need to change this to Donna data. Right here, and then this is that extern unside 8-bit integer. This is the name that we expose to the C code using that assembler macro. Is this, and we use that ampersand to say at the address that this points to. So. And then this is Donna Sprite, and it's 320 by 240. We want it just at 0, 0, and we will. Do we want to bump it down for PAL? Yeah, we'll bump it down for PAL. That's what this is. This is just a standard offset that I'm using if you're running on a PAL Jag. So we'll keep that for now. This is Donna data. And then this is Donna Sprite. And we don't want it to be transparent. That's what I'm doing there. And then we want to attach it to the display. Donna Sprite. And we want it to be a layer below. In fact, we're going to do it 2. So we're going to do it at 13. And then our shadow will be at 14. And then our bug sprite will be at 15 at the highest layer. So I created a function. So this is how I figured out how to keep how to hide any building going on or loading of assets. Is I hide all the display layers that are going to be loaded or have assets loaded to them, load everything, and then I unhide them. And so I had to build a little function that does a range for me, or I can just do one layer or whatever. And it just has a boolean here at the beginning for 0 for off for hide, 1 for on or unhide. Yeah, so there's that. We have some just controller code here for backing out when we're done with that. And then it just hides everything as it detaches everything. And we need to change these to Donna. We'll work on our bug sprite here in just a second. We're going to get the background in there first. Check that and go from there. There we go. Okay, so if we drop this function, if I just copy the name of this function and put it in our main file inside of our switch case statement for this menu, so right here, that should be all we need to do to test this out. And I'm just going to test this in the emulator for now. So clear, make clean, and make. Oh, I'm not cd cd. I just wasn't in the right directory. Oh, and make virtual Jaguar. There we go. There it is. So, and there's Donna. So she's up. Looking all cool on our CRT monitor. Of course, we can't see much of the monitor. Okay, let's get the bug sprite in there. That looks really good for 16-bit sprite. I need to actually, I was having a hard time loading a 24-bit sprite the other day in the removers library. And I don't know if there was just something else I was doing that was causing a problem. I need to figure that out. I swear I figured it out before. I remember I spent like a whole afternoon trying to get it to work and it wasn't working. And I got really frustrated because it's like, I'm pretty sure I've gotten this working before. And so there's just something simple, stupid simple that I was missing. And anyways, okay, let's get the bug in there. Back to tests. So we pulled in our Donna sprite. Now we're going to pull in our Buzz Bomber sprite data. We're going to just focus on the color data for now. We're going to malloc some data or some memory, size of a unsigned 8-bit integer, times by, and I'm just going to copy the rest of this, times by, and this sprite is 32 pixels by 32 pixels, and it's a 16-bit sprite as well. Making a point, I'll optimize these graphics. I'm just not too worried about it right now. We should have plenty of memory here running out of the Jaguar's RAM to do all this. LZ77 unpack, and we need to point it at the name, the assembler name, or label is probably the word for that. I think that's the word that they use for that in assembler. Buzz Bomber, and we need to cast. So we're unpacking to a pointer that's of type phrase, but the LZZ or the LZ77 unpack function expects a pointer for 8-bit, an unsigned 8-bit integer pointer, and so we just have to cast it that to trick it into thinking that that's what we're passing in. And we're fine because as a phrase we're not gonna go outside of the memory bounds that we allotted up here, because it's only going to be unpacking this much data anyways, and so it's fine that we do that. And really what this does, I'm pretty sure we don't need this and it'll run fine, but what it does is it removes a warning when I compile. So and it needs to be a pointer, right? Yeah, that's right. Buzz Bomber data, and we're unpacking to that pointer. Got that. Buzz Bomber sprite equals, and I'm typing this out just for memorization purposes. I like to do that sometimes. 0, 0, and we're just going to put this up in the top corner, and it's of depth. Is it up in the top corner? Not if we're going to be doing this PAL offset. You know what we're going to do? I'm not going to worry about that. We're going to let it start up in the corner, and we're just going to change the background color if it's PAL So we'll have the sprite in the center of the screen, but then there will be these color bars up at the top and bottom. Yeah, that's what we're going to do. Depth and then buzz, bomber data. That's what it's attaching. And this one will be transparent, so we won't do that, but we will attach sprite to display at layer. So settings to our display structure. Oh, whoops. Nope. Sorry. This is buzz bomber sprite, comma, to display at layer. What did we decide? This one is going to be the furthest one up, so 15. Like that. That should give us, well, let's make sure we unpack it correctly. So I'm actually just going to copy all these, and this will be buzz bomber sprite. We make it invisible, and we detach it, and then we free the sprite structure, and then we free the sprite's data structure after that. So I wonder, no, a sprite points to, yeah, it doesn't pack it inside the structure. Yeah. Okay, so we should have our buzz bomber on there. I spelled something wrong. Oh, I didn't save this. There we go. It should be fine now. And there's our buzz bomber. That's strange. Oh, I know why it's doing that. I need to prep that graphic. It has a transparent background right now. The Jag is expecting, not transparency, it's expecting a solid black background. Let me just do that here really quick. Yeah. Oh, actually, that may be a problem. Depends on what they're doing. Yeah, that is going to be a problem. Let's do this. Just like that. Have to make things just slightly not black, or complete like 00000 hex in order for them to not be transparent. That should do the trick. Let's give it a try. Okay, CD GFX test suite and GFX 16. Oops. And then we just run U and run U again, like that. Go back and run U. See if that did the trick. Oh, got us closer. Those pixels were all black. That's why it's giving us a problem. I'll bump this up to 1, 2, 3, 4, like that. See if that does it. We should have, okay, yeah, that should do it. Let me go back. Do this one more time. This is why it'd be useful to have this, the graphics conversion stuff automated. So little changes like this can become quite tedious over time if you're dealing with a ton of assets. Okay, there we go. That's good enough. Yeah, that's fine. Yeah. Just thinking through this really quick. Yeah, that should be good. Okay. So we have our buzz bomber on there, and we're properly removing it once we're outside of the function. Now we need to do our shadow. And the way we're going to do this is we're going to unpack the sprite one more time. So we're going to be repeating. Here, I'm just going to copy this for now. We're going to be unpacking our data one more time, but it's going to be going into BuzzBomber shadow data. It's going to be going into our shadow data pointer instead. And we're going to attach it just the same, but it's going to be on layer 14. But before we attach it, we need to turn all those pixels to a black. Reboot says if you are having scores or times, you need to adjust sprite scroll speeds to keep it fair in NTSC. Oh, that's a good point because you're refreshing at different rates. Huh. And so that's going to affect scores and stuff. That is, I don't quite understand that. If you are having scores or times, yeah, timing makes sense to me. Times, the scores thing doesn't make sense. I guess if scores are tied into your timing, that makes sense. Scroll speeds make sense. Is okay, I understand, because there is scroll speeds are going to be at different rates. You're going to have to adjust like point allotment based on time because your timings are different. That makes sense in order to keep it fair between the two different regions. Okay, yeah, that makes sense. So that's good to know. I'm just wondering if I have anything right now that might. I do, because I'm adding a clock to Audit Will Be Watching, and it's close to real time. And there may be some score elements tied into that. Oh, you know what is tied into that? So right now, Cat 5, the robot, he has a battery that will drain or fill up, and that will be tied into time. And so that will need to be adjusted for 50 and 60 hertz refresh. So that is really good to know. Thanks for bringing that up. I don't have my head wrapped around it completely yet, but when I approach that, I'm going to have to get that figured out. So you need to move sprites faster per frame in PAL. Yeah, that makes sense too with scroll speeds. So that was obvious. What wasn't obvious to me was the scores, like point scores and stuff like that. But I think I have that figured out now. So okay, so we need to go through and change each pixel here with a for loop. Int I, not doing that, I equals 0, and as long as I doesn't equal how do I want to do this? Can I just use a size of? I don't know if I can. Let's give it a try. I'm actually curious. I've never done this before. Can we do size of buzz? If anybody knows C in the audience, maybe you can tell me if I'm heading to trouble or not by doing this. I plus plus. It'd be cool if I could do this, because it means I don't have to do this math each time it goes through that for loop. So it'll do this a bit faster. Let's assume it's going to work. I guess what we can do to check that really quick is we can actually print this to the screen. Fprint f debug console, and it's just going to give us an integer size of that. I can just print this to the screen. Need to turn on our debugger right there, like that. Oh, what didn't you like? Oh, no, it doesn't like that. Yeah, so we may need to cast it. Let's see. Can I do that? Cast it as a what's it expecting? Yeah, just as an integer. Let's see if it'll work with that. But we also need an I. Just an integer up there. Okay. Let's see if it'll do it. 4. Yeah, that definitely wasn't right. Yeah, so that won't work. Let's see here, 4. Yeah, it's definitely not going to work. So yeah, I just have to do the math here. I wonder. I'm going to take a look at the sprite structure really quick. Because it may store that data. Well, I know it does store some data. It's not going to store that exact value, though. I guess I can just hard code it. So 32 times 32 times 2. Oh, wait. Am I doing it this way? Let's see here. If I'm going to be using a memset command, it's going to expect an 8-bit value. So yeah, it is times 2 technically. So that's 2048 bytes that it's going to be going through. And there's probably a faster way to do this, but I'm not too worried about it here because this is just transitioning in. It'll be fast enough. I got to remember how to do this now too. Mem. Oh no. Int or uint int an unsigned 8-bit integer called byte. So what we're going to be doing is we're going to be scanning the sprite pixel by pixel, and what we have to do is we have to pull that in. No, we don't. Yes, we do. We have to check to make sure that it isn't black, and if it isn't a black pixel, we want to paint it to a near black. That's how we're doing this. Equals mem copy. Or no. Let's see here. I think I just need to set this to 0. And then we do a mem copy. The destination is the address at byte. I think this is right. I'm gonna have to go look at some code for this. I've done this before, and so, but I haven't memorized this. So the destination and the source is our data, but we're bringing it in. Let's see here. Oh no, yeah, that's right. I think we have to cast it as an unsigned 8-bit pointer, and then it's plus I. Pretty sure that's right. We'll find out here pretty quick. Yeah. Goes through, copies it to byte, and then if this is actually going to be a problem, but 16-bit images are 2 bytes per pixel. Yeah, and so I understand that. The Mem Copy function will only copy a byte at a time, and so I have a couple options. I can copy in a pair and do the comparison that way, which I'm thinking I'm going to have to do. I was kind of hoping I could just check every byte, because what I'm doing is I'm just checking to see if there's if the color data is anything but 0. The issue is with that is you may have a 2 bytes where the first byte is 0, even though it is a color of some sort. And so I think I'm going to have to do this in pairs. I'm just deciding how I want to do this. Because what we do is because it's 1024 is what it would be. That's how many pixels we're looking at. And then uint unsigned 16-bit. Let's go ahead and just do it this way. And this is pixel color. And just for legibility, that's what we're looking for. I just want to make sure I get this offset correct. Because we want to go every 2 bytes. So I'm just going to create another integer here called pixel offset equals I times 2. And then, yeah, this should work. It's going to complain about this because it's not a 8-bit integer. But I think we can trick it here. Bytes, bytes, and test. Yep. Pixel offset. So this is going to be, just so this is legible, plus 0. That'll be our first byte. And then our second byte will be a plus 1, like that. If this is correct, I'm pretty sure this is correct. And then this needs to be changed to pixel. I'm just going to call this pixel. At pixel. Like that. See, I'm wondering if I can. Yeah, I think I can do this. No, yes, I can. What I have to do is bit shift this. So we bit shift it 8 bits. Equals 8 bits. And that will store the first byte, and then we're copying. No, this won't work. I do have to do 2 separate. Okay, let's be verbose about this, so I don't confuse myself. I'm gonna confuse myself. First byte equals 0x0, and second byte. That's how we're gonna do this. Second byte. So we get our first byte. First byte, and then our second byte, second byte, and then we combine them. There's probably a quicker way to do this, but this is how I'm going to do it. So our pixel equals our first byte and second byte. And we OR those together. Our first byte is first byte, bit shift 8 bits, like that. And then we just OR our second byte. Yeah, like that. That should do it. It should give us our pixel. We'll be able to check this. And then we do pixel, if pixel does not equal 0x000, or transparent pixel in this case, then we can set it to something just off of black. And so we mem set our destination, which is, it's just the same thing. Let's see here. Yeah. Destination, a value of red, green, blue, or red, blue, green. No need to bit shift. The OR will do it. Really? So if we have our value here, this is our first byte, and then this is our second byte, right? Let me comment that out. Don't you have to shift the first byte over so it's over here before we OR the second byte? Pretty sure you have to do that. Well, let's check. We can check that. Let's just do a faux example. So our first byte, let's just say that's FF, and then this is AA, like that. What we can do is print that out. Let's try not doing the bit shift. Let me get rid of that. That'd be awesome if that's true. All you want the color though you were testing for blank. Well, and see, if it was an 8-bit image, I wouldn't bit shift it. But because it's 16-bit, what I have to do is I have to copy, and I realize this is probably not the fastest way to do this, but because each pixel is 2 bytes, I have to copy it out using 1 byte at a time. And so I store both of those, and then I recombine it so I can do the test to see if it's actually a color or just black. So pretty sure I need that byte shift for this case, for the way I'm doing it. And again, it may not be the best way to do it. I realize that. So I just want to get something that works for now. If you want the color, you need to shift. Yeah. And I want to test the actual color. Because, so for example, there may be a color that's hex 00AA, right? And if I'm not, or sorry, let's do this. If I'm not testing the second byte, it's FF00. If I'm testing just each byte separately, not as an individual color, I may miss a pixel. It may actually have color, but I've only tested 1 byte at a time instead of the pair together. That can, yeah, I may miss a pixel, and so I'm pretty sure that these C code functions, this is all standard C with Mem Copy. They're all, because you can't tell it how many bytes to pull out with this Mem Copy function, but with Mem Set, I only need to run this once because you can tell it how many bytes to set, which is nice. And so I'm going to do... I'm going to set it with a color of 1 bit shift 11 bits, 1 bit shift 5 bits for the blue, and then 2 for the green. And then we're going to be setting 2 bytes. Oh, yeah, in fact, that means I don't need this. I can just do pixel offset because it's just going to fill in those 2 bytes with off black. So that should do the trick. We'll find out. Honestly, I'm not too confident in myself in this regard. I've done this before, but I think I have something wrong with my syntax here, making sure I'm pointing to the right bytes. It seems like something might be off there. I gotta change a few other things here. Sprite, shadow data, and we can actually test this out right now. I'm just going to drop it 32 by 32 pixels on the X and Y just so we can see it. Let's run a make command. Yeah, I have some sort of syntax error. Too few arguments. Oh, wait a second. Can we copy? I may just be remembering this function incorrectly. Let me jump over. C code, Mem Copy. Oh, you can copy over 2 bytes. That doesn't really help us though, because it's still expecting. Let's see here. This void destination is void as well. Copy n characters from memory source. Sorry, you guys can't see this right now. I'm just looking at some C code documentation. Destination, this is a pointer to the destination array where the content is typecasted to a pointer of type void. So it's void. We should string copy source destination. So maybe I just need to make sure my source and, well, no, that doesn't work. Oh yeah, I just need to make sure that my source and destination are casted the same. So I should be able to just copy over the whole color. Let's just do this for now, in case I want to go back to this. And pixel. So we should only need to do this once. Got to go. We'll watch the rest in the morning. Good luck. Thanks for stopping by, CJ. We'll see you tomorrow morning. Have a good night. Hope your day went well. Hope tomorrow goes well too. So, see ya. Let's see here. Buzz Bomber. Shadow data. And we should be able to just do... I can switch that back to I if I want to, but I'm not going to do that right now. I think what it's just expecting here is for the size how many bytes that you want, and so we want 2 bytes. What I'm wondering is if we cast this as a 16-bit, unsigned 16-bit like that, that it will just go through each pixel that way. Get rid of that. Check that. How can we test this? What is the best way to test this? One way we could test it is look at a pixel that has color. So 0, 1, 2. The second array value should be a colored pixel. And so if I just... In fact, let's get rid of our for loop for now. I want to test this to make sure that it works. I've never done this before, so we copy that in. Oh, wait a second. I don't think this is going to work, but let's take a look at it anyways. Do I still have my F print? Let's go ahead and copy this up, so I don't have to type that out again. So we copy it in. We're just going to print it out as a hex value. Yes. And then, yeah, that's our pixel. Pixel, like that. Pixel offset. Where am I still? Yeah, right there. Okay. And I'm expecting something other than 0, but that is 16 bits long. And it didn't work. It is showing up though. It's right there. We just haven't turned it black yet. So what I'm thinking we have to do is this does need to be casted as an 8-bit integer. And our pixel offset is going to be plus. Times. Yeah, times 2. Yes, times 2. And then we copy in 2 bytes from that position into our unsigned 16-bit integer. Mem Copy. There's something I'm messing up with the syntax here. See if I can find it here really quick. Common assets, tests. Scroll test. No, it's not complaining about anything. Just some unused variables in that file. So I must be doing that right. Here, let me do Mem Copy. Do a search. Just want to see where else. Yeah, ampersand. We cast it as an 8-bit. Unsigned 8-bit pointer, and then just plus I. So yeah, we're doing it correctly. Oh, I messed up. This needs to be, because right now it's just 0. This needs to be, it was our second times 2. There we go. That should hopefully give us a different value. Cool. I don't know if that's the correct value. In fact, we can check. Can we check that? Not quickly. I'm going to assume that's the correct value, that is working. So we can Control D that. I'm going to put pixel offset back in there and reintroduce our for loop. We don't need U. Don't need any. Don't need that. Don't need that. We do need our check. Pixel offset pointer, and we're just sending it this value. I think I need to wrap this in one more set of parentheses. Yeah, that should work. And we're sending over 2 bytes. Let's see if that works. Hey, it worked. It's not the right color, but it did work. Let's see here. Let me do... what's a quick way of doing this? Yeah, let's just do it this way. Int new color. Eventually I'll go in and hard code this, but for now we're just gonna do that. And this is a uint 16, unsigned 16-bit integer, shift 5, 2. And then I think it just doesn't like me doing all that math right there in the parameter. I don't know why it would have a problem with that, but I think that's what it's complaining about. And I think we're actually writing to the wrong thing. Oh, it's still green. Why is it still green? 1, 1, 2. That should be working. Let's make it all. I'm just wondering if there's something I'm missing here. I'm gonna make it all red and see. That's strange. That's really strange. New color. Ah, it's only writing this byte. That's why. Let me go check memset here really quick in documentation. Because I'm pretty sure it works the same for the most part. Memset 8 times size of character. Fill 8 characters. Oh, okay, so what we need to do... Well, no, that doesn't help us. This does not help us. Here's what we can do. We run this twice. And we have to send it our 2 bytes, and so I do need to do the math on this. Do I want to just do it in code? Just do it in code. So our new color, let's do this. Let me go back to this. That's our new color. This gives us the slightly not black color. And then uint 8, we're bringing back our first byte. Equals, and it's just, we're just going to mask the first byte and then bit shift it. And 0x ff, so we're masking the first byte, that we want to keep, and then we bit shift it 8 bits. So that's our first byte. I'm going to just put that all in parentheses just in case. Don't think we have to do that, but. And then our second byte, we're just masking the first or the second byte like that, and we don't need to bit shift it because it's already what it needs to be, like that. And then we run 2 mem sets at our pixel offset 0 and +1, like that. And we just copy in 1 byte for each one of those, and this is first byte, and then this is second byte. Again, there's probably a smarter way to do this, but I think this will work. We'll find out. Well, it kind of worked. Why are we having an issue there? It's just not writing to the correct place. That's why it's just a solid green. Here, let's do this. Let's figure out our first byte. First byte. Video drop shadow is 88. Is that right? Yeah, I'm pretty sure that's right. So our first value is 88. And then second byte. Second byte. Our second byte is... I'm just having this do the math for me so I can... is 22. So our hex value, our final hex value is going to be 0x8822, like that. That doesn't seem right to me. That feels really high. Let me figure this out. Okay, so binary. I just have a calculator pulled up here. It's going to be our first 5 bits, so 0, 0, or it's just going to be 1. Then our next 5 bits are going to be 0 and 2, 3, 4, then 1, and then 2 is 1, 0. Yes. So that's again going to, no, it's going to be 1, 2, 3, 4 zeros, 1, 0, like that. And our hex value is 842, I believe. So 842, that still doesn't seem right. Let me count that again. 1, yeah. Yeah, so 0842 is our value. 0x0842 is our hex value. Right? Oh, why did I delete those? There we go. This doesn't. Why can't I just copy over that 16-bit value? That is really bizarre to me. Let's see if this makes a difference. Don't think. Oh, it's black. That must have made a difference. What I'm confused by is why can't I just do this? New color. Like there's no reason. It's copy over. Oh, because it's copying over just a byte of that 16-bit value. So it's only copying over the first 8 bits, which is green, and that's why it keeps coming over. It's almost green. It's a few bits. It's 4 bits of blue and 8 bits of green. Yeah, pretty sure that's what it's doing. And then it's just copying that twice. It's duplicating this twice. That's why that's not working. That's why we have to do it this way. Okay, well, we have a solution. Okay, we have our shadow. It took way longer than it should have. Let me unload that properly really quick. Shadow, sprite, and shadow data. There we go. Just make sure that's good. I'm gonna go in and out of that a few times. See if I can do that quickly here. Yeah. Looks like it's loading fine. Okay. What I'm curious about is I thought that the shadow would be further down on the display. The shadow data. We unpack it. Copy the... Oh, there we go. Shadow. Shadow. If I can learn how to spell shadow. There we go. Okay, that should be correct now. Check it one more time. Yeah, there we go. So, and they don't have it offset quite that much. I think they have it, it's only like 16, it might be half that. Maybe it's 8, I'm not sure. In the demo, it's offset quite a bit to give it a nice 3D effect. Yeah, it's something like that. I'm going to make it an odd number like 13. I think they'll aesthetically feel better. Yeah, that's going to feel better. Okay, now we need to move it around. Do I want to do another function? Nah, let's just do it in code here. So, again, I should probably be looking at their code for this, but I like doing this from scratch because I usually do it a little bit different every time I do this, and so anyways, when I do something like this, so it's a good way to learn. Maybe we'll conform my code to their code a little bit later on, but right now I'm just looking to get it to work to mimic what they're doing. So move bug. We need to create some variables for our bug. We're going to create just a vector, a bug vector for x and y. And I'm just going to put that all in an array. The first value will be x, second value will be y. We're going to give those some initial values, so we're going to give it x1 and y1. So they'll both be going, on the y it will be going down, and on the x it will be going right to begin with. And we'll just have a function here that goes through, that will just update the sprite position. So buzz bomber sprite x plus equals bug vector 0, that's our x, times by speed. And int bug speed. And we're just going to keep that uniform on the x and y, equals 2. That's arbitrary right now. That may be 1 in the future, but for now it's arbitrary. Like that. And we do the same thing for the y position. Y. The reason why I'm separating out the vectors on the x and y is because we'll be testing the boundaries at the top of the screen to make it bounce. And we're just going to be inverting the vector, basically, to do that. We will tie in our shadow later. We won't, well, let's do it now. So buzz bomber, we just need to tell the shadow to match that position once we update it. Shadow sprite x equals x plus 13. That was the offset. So we just match the x position of our main sprite and then offset it by whatever our drop shadow needs to be offset by. And we do that for the Y position as well. So we should actually see our bug move. He won't stay in the screen, but he will move. And the shadow will move with him. Okay. And now we need to do a bug collision. And we do some checks. So we're going to test the X first. Do you think we'll ever see a new Jag title that uses the 3D capabilities again? There have been quite a few, actually, just in the last 2 years. Dr. Typo has done a few. There's one called Abyss. It's actually pretty impressive. I mean, it's I think there's still flat shaded polygons. Is he using ground shading? I don't think he is. He's just using flat shaded polygons, but that runs pretty darn well. It's a little submarine game. You just go down, you can dive up and down. There's some enemies that shoot missiles at you, and you can shoot back at them, and you have a few mission objectives. It's a small game, but it's all 3D, and it works pretty good. There's that one. He's also done a remix of Tube SE called Tube 2020, which is just, it's a 3D tube that you go down, and you have to try to stay in the center and finish the course as quickly as possible. So there are some 3D games happening on the Jag. I think Phobos is planning on doing something in 3D. He's the one that did he's the individual that did Kings of Edom, Asterite, and a few other like Spidey X and a few others. So yeah, it'd be cool to see another racing game. There's already at least one decent racer on the Jag, and that's World Tour Racing. I did a stream on that a few weeks ago, actually. It's a lot better than I remember it being. It's a pretty good racer. And then there's always Checkered Flag. It doesn't. It's not the best racing game in the world, but it works. But yeah, 3D is definitely, when you're going from the 2D to the 3D world, it's quite the step up on any platform, and on the Jag it's a little bit more difficult because in order, again, this is someone who hasn't done a lot in 3D on the Jag, because of how unique the hardware is. It's something that takes a great amount of experience to accomplish. So, and the thing is there's people in the homebrew community that are slowly getting to that point, and so I would imagine if this whole retro gaming scene keeps its steam, you'll be seeing more 3D stuff on the Jag in the future. What I would caution people is, and we kind of have this going on right now with Tomb Raider coming over to the Jag, is and I'm not going to say you can't get that game playable, but if you're expecting PlayStation level graphics, I don't think you're going to get them. I think you're going to be disappointed. So yeah, World Tour Racing's a lot of fun. It is a CD exclusive. That's the one drawback. I don't know how well it plays on the Jag game drive yet, the SD card reader. I actually haven't tested. I don't think I've tested that one out. It should, besides the videos, it should work fine, I imagine. It may have some issues with the music streaming. I don't know though. Maybe we'll have to, I might have to do a stream one of these days where we just test out CD games on the Jag GD. It might be a really boring stream though, because I think the issues I'm running into with my SD card reader are it's the SD card I'm using. Like most CD games boot, but there's always a gotcha. There's something that doesn't load right. Like, for example, last week I was talking about Myst, which I have tested on the Jag GD, and it's playable, but the videos, they'll just stop. So, for example, at the very beginning when Atris is talking to you through the viewer, it'll play part of that. The video will stop, and then it'll give up. The game still plays, it just stops playing the video. So, wait, Tomb Raider is coming to the Jag? Holy hell, that sounds cool. I always look at the games for what they are. Playing anything like the Jag would be so cool. So right now it runs, just to give you an idea how well it runs. And here's the thing. it's something you don't want to really get your hopes high for, because it's a massive undertaking to even get it so it's more than 1 frame a second. Right now it's 1 frame every 2 seconds, and I mean you count to 2, 1, 2, and then you get a new frame on your screen. So it's not even playable right now. It's a glorified slideshow, but it is running, and it's not utilizing the GPU or anything like that. The individual who's been doing the ports to like the Game Boy Advance and the Sega 32X for Tomb Raider, it's OpenLore. It's the Open Tomb Raider engine. He's made some huge strides on those platforms. Like on the Game Boy Advance, it's pretty much playable. Like it's slow, but it is playable. And so somebody mentioned that the Jag would it would be cool to see it running on the Jag, and I don't know how much work he's done. Somebody else has done some work just getting it running on the Motorola 68000 processor in the Jag, which that's why it runs so slow. And so it's kind of, I guess you can call that a proof of concept that yes, you can run Tomb Raider on the Jag, but it's not playable in any sense of the word. So again, I would highly suggest keep your hopes moderate. Let a few years pass by before we make a final decision on yes, Tomb Raider can run on the Jag. So because right now I'd say even with that example, I wouldn't consider that running on the Jag. I would say yes, you can get the engine compiling and running on the 68000, but technically you should be able to run it on the Atari ST at this point, but it's never going to run it well. So playable, I guess, is my standard. That's when I'll say yes, it can run on the Jag, is once you have a game that's playable. So right now it's basically a tech demo, and a very poor one at that. So it's a lot better than what I could do. I don't want to cast shade on anybody who's putting effort into it. I think it's awesome that people are attempting it. I think they're going to learn some cool things, which is awesome. But yeah, I'm keeping my expectations low on this one. So okay, let's do some collision detection. So we just need to check, and we're going to check the X and Y independently. So we're going to check the X position. Let's see here. Yeah, we're fine doing it this way. From the PS1 generation, wonder if it would be possible, since it's not much. My dream would be Resident Evil 1 on the Jag. See, now that I think is a lot more plausible, because we already have a game like Highlander, which is basically a Resident Evil engine, where it has pre-rendered backgrounds and then 3D characters on screen, and that runs fine. In fact, if I imagine, because they had multiple games planned for that, if I remember correctly, given another year or two, they would have optimized that engine so it was running really smooth, very well. So technically, we already know that Resident Evil can run on the Jag. It was just that I believe Resident Evil was a later release, wasn't it? It was like 96, something like that. And by then, the Jag was already a forgotten memory. So. Okay, is less than 0, so the left side of the screen. We swap the vector, and we may do some other equals. I think I can just do that. I learned that trick by looking at their code the other day. I think we can just invert the number by doing that. I'm just gonna do this. This is what I'm used to. Whoops. Give it a negative. And so if it's already a negative number, because a negative times a negative will equal a positive, they'll just flip the vector. So yeah, that should work. And we do it on the Y, which 0 on the Y is the top of the screen. And we swap the vector with that. And then, so we do need to do our Ntsc Pal Check here. So this is our, yeah, I'm not going to comment that. We don't need to. Just going to copy this whole thing. So if it's greater than 320, which is the right side of the screen, we may bump these in a little bit. Swap the vector. And if it's greater than, and so this is tricky. If we need to do an if statement, an inline if statement. So settings Pal, what is it? Pal, I forgot what it is. Let's go take a look. Pal Ntsc, that's what it is. Pal Ntsc. Let's see here, is greater than 0. So if it's greater than 0, that means it's NTSC, and so we don't want to offset it at all, or we want to set it to 240. Otherwise, so if it's PAL, we set it to 288. I believe that's our PAL height. So, and then we swap the vector on that. That should work. That should be all we need to do to get things bouncing around. So, let's take a look. Maybe. Oh yeah, look at that. It's bouncing around. Yeah, so what I'm going to do is we're going to bring it in on the right side and the bottom of the screen a bit. So we'll make this 208. Let's bring them both in by 32 pixels. And 56. It should bounce a little bit better. And we're going to want to mix this up a little bit, so, whoops, wrong. Because it's just going to do the same pattern each time. Well, it's not bad. It's fine. And let's just do, instead of 2, let's do 1 on the speed. And, oh, we forgot to bring in this. So, what is that? 290 or 2. Come on, Will, you can do this. 284. 284. Yeah, it bounces. Ding, ding. There we go. That feels better. Okay. Now we need to flash the shadow on and off. The quick way of doing this, I don't know if this is appropriate, and this is where we may need to go look at their code, but let's try doing it here first. I'm going to call this flash shadow. So every vertical blank, we want it to either flip on or off. So that way every other frame it's on, or every other frame it's off. And so I should be able to just check to see if the shadow is visible. So if Buzz Bomber Shadow Sprite Invisible is equal to 0, so if it's currently on, so we can see the shadow, turn it off. Visible, if I can spell that right. There we go. I'm just going to copy this. So we set it to, so we can't see it. Invisible's turned on. Otherwise, so, and we can just do an else statement on this. Else, so this is the same as just writing out Buzz Bomber Shadow Sprite Invisible equals to 1. So if it's been turned off, turn it back on. But it'll only do that on the next loop. So this should be every other frame. I'm just wondering if there's some more verbose code that would ensure that that happens every other frame. But it looks like that's working in the emulator. just fine. Let's put it onto hardware. So let me go over to our big screen here. This is running on actual Jag hardware this time. Make reset sleep for 2.5 seconds. Clear the screen. Clear the screen, make clean, clean up our project, and then make skunk. Send it over to the skunk. Okay. Okay. Yeah, looks fine over there too. So I assume that's going to work just fine. What I need to do is test it on my CRT. Problem is you guys won't be able to see that. So, but I kind of want to do it just to make sure. Well, I can test that at some other point. It looks fine up on my LCD. Problem is, the reason why I'm curious to see this on an LCD is I'm not familiar with the flashing shadow. What that looks like on my LCD. And so all I can do is assume that it's working right now. But anyways, I think that's good. But yeah, there's that. Hey, we actually finished something on one of these programming streams. I hope this was a little more interesting than the last few. Man, it was pretty bad. I think the last one I did, programming stream, was pretty boring. I assume it was pretty boring for you guys because I just ran into a wall with the text engine, getting the text displaying properly. I've got that worked out though. I am going to turn off here before we call it a stream. I was going to turn off the debug console. So that's not on screen anymore. Turn this back on. Like that. There it is. There's Donna with the sprite. The other thing I need to do here, and I can't do that. Can I do that? No, I don't. I have a Jag where I have the PAL NTS switch on. That's how I've been testing, so I can switch it over to PAL. But I don't have that hooked up as my main Jag. I probably should, but rule number 1 for programming is fun. Man, I wish it was that way all the time. Most of the time it is. I really do enjoy programming. The way I explain it to people, why I enjoy it so much, is it's like a knot. I've always enjoyed untying knots, figuring out how to untie knots, and that's kind of what programming is for me. And so once I learn something, it can get boring because I know how to untie the knot, right? But with the Jag, it's been an adventure because it always seems like there's something I'm missing or I don't quite understand, and so I have to go untie another knot, and I do enjoy that. So it can get frustrating only when solutions don't. You put the time in and you try learning something and you still can't find a solution. That's when it gets frustrating, but that's normal. That's normal, at least for me. That's normal behavior. So, but anyways, yeah. That's what it looks like on the Mega Drive, on the Sega. Here, before we go, we can go a few more minutes here. Let's jump over here to the browser. I was gonna bring up the 240p test suite GitHub, and let's go look at his code for this. Genesis, and it's under tests. It should be near the top. Draw checkerboard, nope, not that. Draw stripes, nope, not that. Drop shadow test. Oh, it looks like he may have some button inputs of some sort. Waterfall. Must change the background or something, so we may be doing some more work here. I just wanted to see specifically how he's moving stuff around and how he's turning, or how he's handling the shadow. Donna tiles, case 1. Okay, so yeah, he has some different backgrounds, I think. So what's going on here? So yeah, Sonic Floor. Yeah, he's Okay, we're not worried about that though. I'm just wondering if he's doing the flash here. It doesn't look like it. Field invert. Set sprite position. Start field invert. Yeah, it looks like he has a variable that he's tracking on and off, I think. Buttons up. And you can manually control the position here. And here, start, exit button A, invert, shadow on odd frames. Okay, yeah, so what he's doing, I'm pretty sure, is tracking frames, and then he only turns it on for the on frames, and then turns it off for the odd frames, and then turns it off for the even frames, or something, or vice versa. Sonic water, he's just animating the water in the background. Clear tile. Press. Oh, this is just swapping the background. Yeah, he must have some different backgrounds. So let me check that in the emulator really quick. Maybe we'll do that here really fast. I can spend a few more minutes. Find that line. There it is. You guys can't see this, unfortunately, but I'm just going to check really quick the actual program. Shadow on odd frames. Oh. So he has a toggle when you hit A or C on the Sega Genesis controller. It switches the flash to happen on odd frames versus even frames. So yeah, we're going to have to do something with that. And then he has different backgrounds. He has the Sonic background, but it's not scrolling. He has a checkered black and white background, a striped black and white background, and then Donna again. So yeah, we're not going to do that today. Well, I don't know. It might be pretty easy to set up that even odd frame. I just need something that tracks frames. Yeah, let's go ahead and do it. I don't think it'll be too difficult. All I do is create another integer called frames that just counts. So we'll start it at 0 and we'll just count it up. So count frames if, in fact, I'm going to do this another way. We're going to do this 1. And so 0 is even, 1 is odd. And so if frames is greater than 0, we count it down. So frames, did I say frames or frame? Yeah, frames. Let's call it frame. Sorry, getting picky. Frame minus minus. And that'll make it 0. Else. And if it ever hits 0, on the next loop, it will set it back to 1. And so that gives us our even odd. So frame equals 1. We just set it back to 1. Okay. And now the trick is telling it to only do it on... Oh, we need a toggle. Int odd even equals, we'll start on evens, and we need to toggle that. And I think he was using A on the controller to toggle that. So odd even, it's just the equals the... Oh, that doesn't work. We'll just do the same thing here. If odd even equals 0, then set it to 1. Odd even equals 1. Else do the invert. Odd, or the opposite, equals 0. like that. Okay, so that toggles our odd even. And now down here where we're setting the shadow, we just need another check. So, oh, wait a second. What's the quickest way of doing this? I know of a verbose way of doing this. So the first thing we need to check is odd and even, right? So there's probably a more condensed way of doing this, but I'm trying to be quick. So if odd, even equals even, so on the even frames, whoops, there, tab all that in. And then we do a check for even, odd or even. So we want it to be visible on the evens. So it'll be invisible on the odds. So we do another check here. If frame is equal to 1, it will be invisible. Else on the evens, in fact, I don't even need this check now. We can get rid of this. We can just do if frame is equal to 1. So on the odds, it will be invisible, and on the evens, it will be visible. And then here, when odd even is set to 1, so we want it to be visible on the odds. So if frame is an odd number, it's visible, else it is invisible. So on the evens, it will be invisible. That should be it. Let's make sure there aren't any syntax errors. Looks like we're fine. I'm going to run this in virtual Jaguar first. Looks fine. We do need an indicator of odd versus even. How can we'll just do this. We'll do in the end, I'll set up some text that shows up at the top, but for now, we'll just use the debug console. Let me turn that back on. There's that. And then we just do an fprint command each time we switch it. Joypad A right here. Fprint F debug console. That's the console we're printing to. And we just want it to display the value, the odd even value. So we know if it's odd or even. I guess that doesn't really tell us, but really just need to check our logic here again. So if it's even, our odd frame, it's turned off, else it's visible. On odd frames, the odd frame is visible and the even frame is, yeah, so we should be fine. We don't need to do this. It should be doing the trick. It should be working. It's kind of hard to tell anyways, because when it switches, it's so quick that it's going to be off. I'm just wondering where it would be visible is on an interlace signal, I believe, on the odd or even frames, because interlace, you have two frames that are swapping interlace between each other, and that's where you would see the difference. So I think that's where you'd see the difference. Anyways, we do have it. Let me push that out to the Jag really quick. We'll test it on hardware. Oh, yeah, 1 second. Turn that debug console back off. We aren't using it. Send it out again. Oh yeah, you can see it switch. I don't know if you can see this on the stream, but when I hit A, you'll see the shadow flash because it's swapping between odd and even frames. So anyways, got that. We'll do the backgrounds another time. But yeah, it's working great. All right, thanks for watching. I'll be working on this again tomorrow morning. Maybe we'll finish this one up. We'll put in the extra backgrounds, and then maybe we'll do some simpler ones that need to be done, like the stripe background and the checkerboard background. Maybe at lunchtime today, I'll do some research on how to properly calculate parallax scrolling with integers. See, that's the hard part. Most tutorials that you'll look up for parallax scrolling, they're using floating point. And I can do that technically with 16 point precision, but looking at the code for the 240p test suite for the Sega Genesis on the GitHub, they're doing some sort of clever math to do integer parallax scrolling. What I need to do is just spend some more time with that and figure it out. So, but oh, sorry, there was a question by dataset user. So when it's all done, will this be available on cartridge and or as a ROM file? Love the whole thing already. So my plan right now is I want to do a pass on everything, get everything that I can finish, that I'm capable of finishing, done. I'm going to approach the group that is in charge of the 240p test suite. I haven't even introduced myself yet, technically. So I'll strike up a conversation with them. And see if they can host the code on their GitHub if they're willing to do that. And so the code will be open source there, and I imagine that they'll want a ROM file available for that. When it comes to cartridges, I guess I could produce some cartridges, or if somebody else like Albert wanted to do that, I just don't know if it's that valuable, if there's enough people to justify that. But the ROM will be available if you want to make your own cartridge, and because it's open source, you're more than willing to do that. And really, I don't think there's anybody in this case. There won't be anything limiting anybody from making cartridges themselves and making money off of it if they want to try to fill that niche. I personally don't want to do it myself. It takes a lot of time to make cartridges. So, but yeah, it'll be available, so you can run it just over a skunk or on your Jag GD if you wanted to do that. So it'll be available. That's kind of the idea, is that there's a tool that people can use to calibrate their monitors that's easily available. So that's the idea behind the 240p test suite project, I believe, generally speaking. But yeah, that'll be available. Yeah, so more of this tomorrow. I just don't know. Let me back out here really quick. So we'll be doing tomorrow. We'll probably just be doing this striped sprite test. I don't want to do the lag or timing reflex tests yet. I need to dig into the code on those and make sure that I'm doing those right, because those are going to be really important to make sure that those are done absolutely right. I don't know how else to explain that. Maybe we'll do the grid scroll and the horizontal and vertical. We'll do these simpler ones tomorrow. I don't know what this backlit zone test is. I need to go take a look at that. And then this alternate between 240p and 480i. The Jag is capable of this. I don't know if I can switch between those on the fly, though. I'm sure there's a way to do it, because I know there's games on the Jag that do switch resolutions on the fly. I just don't even know where to start on that. And so I can affect variables that affect the horizontal clock timing and stuff like that. I just don't know if I can do that on the fly without causing damage or something. And so I may need to send some emails out and talk to people who are way more experienced than me at this and see if that's safe to do the way I'm thinking anyways. So anyways, so tomorrow we'll just focus. We should be able to get through most of these tomorrow, I'm hoping, because they're really simple, just scrolling things. And since I know how to do that effectively now, they should go really fast. So we should be able to get most of this list done tomorrow, which will be most of what the test suite is. Something I haven't implemented, and I probably won't do this on stream just because it'll be boring, are all the help screens. And I have no idea what's in these option menus. I haven't even looked on the Sega Genesis version yet, so we'll see. And then there's an option menu out here, and then I have to figure out the credit screen. And most of that's pretty boring stuff, so I don't know if I want to spend a whole lot of time doing that on stream, but I'll take a look at it over here the next few weeks. But we're closing in pretty quick. I think I'll probably have a first version done in the next few weeks, hopefully, if we keep doing these streams on it. So, but anyways, thanks for watching. Like, subscribe. There's the newsletter at JagCorner.com. There's links in the description. Check that all out. And thanks again for watching. Have a great day. See you tomorrow. Bye.